Hi, Meghla here, and I'm going to handle today the second class of numbers. The first one was about this classification of numbers and divisibility rule, and the second one now you're going to see this factors, multiples, co-prime, HCF and LCM. The first thing what you're going to see here is a prime factorization. So what do you mean by factorization? So this is like writing any composite number, whatever you have, like for example 90, in the form of a prime number. For solving the problems, we need this. This is very important, to write any number in the form of a prime number. So that is what is called prime factorization. So for example, you just take this 90. For this 90, we have to remove, separate all the prime factors. So first thing, the simplest prime number is 2. So when you remove that, it's going to be 45. Then again, you have to take out 3 from this. Then it's going to be 15. Again, one more 3 is remove that. Then it's going to be 5. And then remove that 5. Then it's going to be 1. So it's the end of it. So okay, take all the prime numbers and write here. That is 2 into 3 into 3 into 5 is the number. And combine all like prime numbers. So it's going to be like 2 into 3 square into 5. So this is what is called prime factorization. So you can see this other one, like the second one is like 80. If you want to solve, just keep removing this 2's till this 2's gets over. Then after that, you just start doing with the next prime number. So it's going to be 2 power 4 into 5. So prime factorization can be done in 2 different ways. One is like using factor trees, and the other one is repeated division. So factor trees is just keeps branching this separately, like 36, you have 2 in that, so remove that 2, the remaining is 18. Again, remove this 2 from this, again 9, then again remove 3 from this, another 3. So whatever you have in the form of a prime numbers, combine them together and write it. And the same thing can be done, this we call as an LCM method, where we generally put this L shape and then remove that common factor. So 2, and taking out 18 is there, again 2 you take out, and this so on. So when you have all this in the form of a prime number, just take it. This is called a repeated division method. The next is, what do you mean by factor? So you have factors and multiples. So the factors here, as mentioned here, you have this factors or numbers you multiply together to get another number. So that is 2 numbers when you multiply any 2 number. Doesn't matter if it is prime or composite. So whatever the number it is, when you multiply, you get the third number, and we call these 2 as the factors of the third number. So here also you can see that when 5 into 4 is 20, we call this 5 is a factor of 20 and 4 is a factor of 20. That the one which you are multiplying, they are called factors. The result, whatever you get, is called multiple. So we can say this is a multiple of 4 as well as this is a multiple of 5. And multiples and factors, when you consider, multiples are nothing but that particular number, whatever you have, into 1, into 2, into 3, into 4, and so on. So there is no limit for the multiples. So this first 4 multiples here listed out here as 12, 24, 36, 48. So the next number you can just see it is going to be 60 and so on. There is no limit for that. Whereas factors, when you consider, there is a limit. So factors are numbers that multiplied to get a given number. So this 12, if you consider, how do you get this 12? Like here we are taking 12 into 1, but here we are also considering 12 into 1, but we are not taking this like multiples here. We are just considering the result as always to be 12. So what are the numbers you can multiply to get this? So 1 into 12 or 2 into 6 or 3 into 4, you're getting this. Beyond this, I don't think there's any other number, the integer which you can multiply and get 12. So that this is limited, whereas here it is no, there is no limit. So these are the factors of 12. The next, number of factors. The most important for you is finding out the number of factors of any number. So you will be getting questions on that. So this has to be very clear. We have some shortcuts also. But first, let us list out the factors. Like in the previous problem also, you are seeing for 12, you had 6 factors. So here, for example, if you want to see for 60, it's the same thing. Like the number of factors, if you have to find out, what you can do is the 60, like you have to, these are all called factors. Whatever the numbers you're dividing by, they are called factors. Or we can also consider the other way. We can say that product of the 2 numbers have to be 60. So which 2 numbers will give you 60? So 1 into 60 is going to give you 60. Therefore, 1 becomes 1 factor, 60 becomes another factor. Similarly, 2 into 30 or 3 into 20 or 4 into 15, 5 into 12 or 6 into 10. Beyond this, after 6 you have 7, which is not a factor of 60, 8 is not a factor of 60, 9 is not a factor of 60, and then 10 has come here. So that means you have taken all the numbers which is to be considered. So these are all the factors of 60. And next, the one I said, like you have the shortcut to find this one. You don't have to list out all the time, like 60 or 12 is a small number where you can just list out and get the factors. Whereas when the number is quite big, it is not that easy to find the factors. So what we do here is we have to go for the formula. The formula is, suppose you have to find the number of factors of n, first prime factorize and write that n in the form of a prime number. So when you write it in the form of a prime number, like P, Q, R are the prime factors, and raise to the powers, like we have seen earlier for 90 in the same way. Yeah, we have to just take this and then take only the powers now. You are writing in the form of a prime number raised to some powers. Take only the powers now, increase each of this power by 1 and multiply them to get the number of factors. So now we are going to see that. Like one of the example I can show you directly here, there is number of factors. What for the 24, if you had to find, first write down this 24 in the form of a prime factors, that is 2 power 3 into 3 power 1, and now this 2 power 3 list out in this column. So what are all the different factors you can have? 2 power 0 is also one of the factors. There is nothing but 1. 1 is definitely a factor of any number, so we have to start with 2 power 0. Then 2 power 1 is another factor. The 2 power 1 you can divide this way. So similarly 2 power 3, 2 power 4, that's a maximum. You cannot have 2 power 4. 16, 24 is not divisible by 16. So we have to restrict up to this number, that is 8. So we can divide 24 by 8, but not by the next number 16. Similarly here you have 3 power 1, so we can consider from 3 power 0 to 3 power 1. So when you list out this and take the product of these two, 2 power 0 to 3 power 0 is nothing but 1. And the same thing, like 2 power 1 into 3 power 0 is going to be 2. You take it in this way. This is going to be 4, this is going to be 8, and then this is again 3 power 1 into 2 power 0 is 3. Then the product of 2 power 1 to 3 power 1 is 6. 2 power 2 into 3 power 1 is going to be 12 and 24. So these are all the different factors which you have. That is, you have totally 8 factors. Or you can say the number of columns you have is 4 here, and the number of rows here it is 2. Therefore, we can say you can just consider this columns and row. So these columns, when you consider, there are 4 of them, and here the rows you can consider as 2, right? So sorry, yeah, this 2. So what you can do here is you can just take this number of factors is nothing but number of rows into columns. So 4 into 2, that is nothing but 8. So you have 8 of them. So here you can see that you can also do this by using this formula, 2 power 3 into 3 power 1, which you have. You can just take this power and increase by 1. So that becomes 4, and this power and increase by 1, that becomes 2, and then multiply to get the number of factors. That's what is shown here. Okay, so why we are increasing this by 1? That is because, as you know that when it is 3, you need to take from 0 to 3. 0, 1, 2, 3. So there are 4 of them. Similarly, when it is 3 power 1, you are taking 0 to 1. So there are 2 of them. So the 0 is one thing which is included in this. Therefore, we are adding 1 to that. And similarly, you can just find out for 480, the number of factors. When you factorize, this is going to be the number. So 5 has to be increased by 1, that becomes 6. 1 will become 2, this 1 will become 2, then multiply that to get the number of factors. So in general, this is a method. N equal to A power P, B power Q, and C power Q, and so on, R, and so on. When it goes on, then the number of factors is just take the powers, increase that by 1 and multiply. So some of the numbers are given here, the number of factors of each number, like 16 has 5, 36 has 9, 20 has 6, and so on. A perfect square has odd number of factors. Please remember this. Any perfect square where the powers will be even, so when you increase the powers by 1, it becomes odd, and the product of those odd numbers is going to be odd. Therefore, any perfect square will have odd number of factors. A square of a prime number has exactly 3 factors. So any square of the prime number, you can just consider the prime number itself will have 2 factors, and squaring them will be another factor. So exactly 3 factors is going to be. And now coprimes. So coprime, what do you mean by coprime? So coprime is nothing but a set of numbers which do not have any other common factor other than 1 are called coprime or relative prime. So it can be considered in both the ways, both the same meaning. This means that no numbers, this means those numbers whose HCF is 1. So for example, 8 and 9 have no other common factor other than 1. So 8 and 9 or any consecutive numbers, when you consider, they are co-prime to each other. Any two prime numbers are co-prime to each other, or any prime number and the composite number where they don't have anything in common are co-prime to each other. So it doesn't mean that only the consecutive numbers. Randomly, any two composite number also can be co-prime to each other. For example, I can consider say 21, which is a multiple of 7 I can take, and I can consider 44. Both are composite numbers. So 21 and 44 doesn't have anything in common, and so on. Okay, next. These are the examples given here. Next, you're going to see this LCM and HCF. So LCM and HCF. Here, HCF is nothing but highest common factor. LCM is least common multiple. So find the LCM of 4 and 6. Multiples of 4 are this given here, and then 6 is given. So we are going to see these are all the multiples, and we have to go for the common multiples. You can see that the common multiples here is 12 and 24 and so on. So these are the common multiples, and the least of this is nothing but 12. So your answer is 12. So this is going to be the answer, right? That is LCM. Similarly, when you go for HCF of the numbers, consider the factors of 18 and 24. So when you take the factors of 18 and 24, 18 factors are given here and 24 is given here. You know that the least is always going to be 1. So you can't say for the least, you have to go for the highest. So which are all the common factors you have? 1 is common, 2 is common, 3 is common, and 6 is common. Beyond this, you don't have anything in common. So you're going for the highest common factor, which is nothing but 6. That's the answer. Next. LCM and HCF. So you can do this in two different ways. Like we just now I showed that. You can also go for this one. Just find out like this one, the L division which we do it. So repeated division, you can say. Remove this common multiple factors, whatever you have. This 24 and 36, you have 2 as a common. Remove that. And then the next, again, you have 2 common. Remove that. Then you don't have common 2 here, but you have common 3. So remove the common 3. The left out is 2 and 3. When you multiply all this, that becomes your LCM. So 2 into 2, again 3 into 2 into 3. So that is what is your LCM. Product of all this will give you LCM. In general, we can say LCM is a number. The 72 is the LCM here. And we need to see that the given numbers are the factors of this LCM. So 24 and 36 is given. You have to check whether 72 is divisible by 24 and 72 is divisible by 36, and that becomes LCM. Similarly, when you go for this in HCF, it's the same process you're going to do, but you are just going to take the common factors, whatever you're taking here, not the one which is left out. So when you consider this, that becomes your HCF. Like here we are taking all the numbers, but here we are taking only the common one. So remove this. This is not common to both. This is left out of 6 and 9. So this is what is common. So 2 into 2 into 3 is 12. And here also, it is the other way. When you go for, this is for LCM. And when you go for HCF, so what you have to see is this 24 and 36 when you consider, the factor is nothing but this. You just have to see whether 24 is divisible by 12 and 36 is also divisible by 12. Otherwise, that's not a common factor. Next. LCM of fractions. So we can use this following direct formula. That is, HCF of fraction is nothing but HCF of the numerator divided by LCM of the denominator of the fractions. So any fraction given here, like suppose you are given like 2 by 3, then 4 by 7, then we can say HCF of the fraction is HCF of the denominator. So here you're going to consider 2, 4. Take the HCF of those two and LCM of the denominator. So 3 and 7. And same thing here, you're going to say the same value here, but LCM of 2 and 4 divided by HCF of 3 and 7. So that's a formula. So we'll see one example here. Find the HCF and LCM of the two fractions, 6 by 9 and 12 by 15. So here you can see the numerator of 6 and 12. Numerators here are 6 and 12. So I'm just taking these two and find the HCF of these two and LCM. So their HCF is 6. 6 and 12, HCF is 6 and LCM is 12. And denominator 9 and 15, when you consider, your LCM is going to be 45 and HCF is going to be 3. So hence we have this HCF as HCF of the numerator. So numerator is here, HCF is 6 and LCM of the denominator, that is 45 or 2 by 15. Similarly, when you go for LCM, LCM of the numerator, which is 12, divided by HCF of the denominator, which is 3. So 12 by 3 is 4. Okay. So this is the end of it. We'll see in the next class. Thank you.